Warm up for lesson 4-3, solving quadratic equations. Pause. Here's the answer. Pause. Here's the answer. Lesson 4-3, solving quadratic equations by factoring. Let's take a look at a factored form of a quadratic equation. Notice the factors, x minus p, x minus q. P and q stand for the x-intercepts. Now, in this particular problem, we have the standard form and we have the factored form and we have the graph. Now notice that 2 and 6 are the x-intercepts, and 2 and 6 are also the numbers we put in the factored form. They're right behind the minus signs. Now, if you were to multiply all this out, you would get back to this standard form. Let's remember the FOIL method. The FOIL method is really a distributive property. It's where, when we have the factored form, we can distribute our x to each one of these and our -6 to each one of these and actually get our quadratic in standard form. What if I gave you the roots, -1/3 and +6? How would we go about writing the equation in standard form? Well, this is what we could do. We write out x minus p, x minus q. Remember that this p and q stand for the intercepts. So -1/3 is substituted in here, 6 is substituted in here. We simplify a little bit, do the distributive property or FOIL. We're going to get this. When we have a fraction, you can multiply by 3 so that the fraction doesn't show up. Let's go ahead and do this problem, and I'm going to do it from scratch. So I'm going to write x minus, and I'm going to put in 3/4 here because that's one of my roots, one of my x-intercepts, and then I'm going to put -5. Now I'm going to clean up a little bit before I start multiplying, and I should be writing equals 0. Okay, I'm going to do FOIL. This will be x squared minus 3/4 x plus 5x minus, and I'm going to take a -3/4 and times it by 5/1, and that'll be -15/4 equals 0. Okay, now before I actually try to put the x's together, I think what I'm going to do is I'm going to multiply this whole thing by the number 4, and when I multiply this whole thing by the 4, it still be 0. So I'm going to get a 4x squared minus 3x plus 20x minus 15 is equal to 0. I'm going to combine like terms. 4x squared plus 17x minus 15 is equal to 0. So we say that this is the standard form for this equation. Now you try. Pause and try to do the problem. My suggestion is that you start off with x minus, and then what you're going to do is you're going to put the -3/4 right into here, the 5 right into here, and see if you can get through your algebra. And here is the answer. Solve equations by factoring. If we're in the factored form, we can use what we call the zero product property. And this says that whenever two numbers multiply to equal to 0, one of them or both of them are equal to 0. So this is in factored form. We're going to set each factor equal to 0, and then we can go ahead and solve. X is equal to -3, x is equal to 5. And so we have found the solution. Let's take a look at this problem. This problem doesn't require FOIL. What it requires is the GCF. So we're going to look for the largest GCF that this two terms can have. And once we have it in its factor form, we set each one equal to 0 and solve. Now, if finding the GCF is difficult for you, then why don't you put them all into factored form, and then what you can do is you can look for the common factors, like I have here, and then we're going to factor it out, so 5x, and then what I have left here is a 4x, and what I have left here is a +3, and I'm going to set each factor equal to 0. And so x will be equal to 0, or x will be equal to negative 3/4. Over here, I've already factored it out. 4y is equal to 0, or y plus 4 is equal to 0. So y is equal to 0, or y is equal to negative 4. Here again, I've written it all out. If you don't need to do this, this is fine. If you can factor it out, now set each factor equal to 0. And our answer here will be 0, and a will be equal to negative 3. All right, check your progress. Pause to see if you can do the problem. And this is another GCF factor technique. Okay, let's take a look at the perfect squares and difference of squares, because they have a different factoring technique. Now, how can you tell if you have a perfect square? Well, this is x times x, and this is 8 times 8. And if you end up taking one factor for each, so that'll be an 8x, and you times it by 2, and that'll be 16x. And if that 16x is right here, then you know you have a perfect square. What is a perfect square? Well, it means that when you factor it, both factors are going to be exactly the same. So split up the x, split up the 64, each of them are going to have a plus, so we know we have the same thing. You should only set one of them equal to 0 to try to get the answer, because the other one will be the same thing. Take the 64 to the other side, and this is what we call a difference of two squares. Here's the difference, and a square on one side, a square on the other side. To do this problem, you're going to split up the x squared, you're going to split up the 8 squared, put a plus in one and a minus in the other, set them both equal to 0, and then solve. All right, let's do 3 problems. The first one I can tell is a perfect square problem. How can I tell? Well, this is 2a times 2a, and this is 3 times 3. And if I were to take one factor from each, that's going to be 6a, and this happens to be double that, so I know it's going to be a perfect square. So how do we go about doing that? We know they're going to be exactly the same. This is going to be 3 and 3. This is going to be 2x and 2x. And since the middle term is minus, they're both minuses. So perfect square means they're both the same. Set just one equal to 0. 2x is equal to 3. X is equal to 3/2. This is definitely a GCF problem. I'm going to factor out a 9. They have a common. Factor 9 and an x, and what do I have left? 9x minus 1 is equal to 0. Set each equal to 0, and we're going to get x is equal to 0, and then x is equal to 1/9. Over here is a GCF again, 3 and a, and then we're going to left with a 2a and a minus 1 equal to 0. So 3a is equal to 0, 2a minus 1 is equal to 0, a is equal to 0, or a is equal to 1/2. Okay, one more. Let's go ahead and do just some regular factoring. This isn't a difference of two squares. This is not a perfect square. This is not a GCF. It's just factoring. So let's just go ahead and factor. We're going to split up the x. We're going to think about 30. This means the signs are both going to be the same. 30 times 1, 10 times 3, 6 times 5. I think there's a 2 times 15. So what we want to do is we want to find a set of factors whose sum will be 11, and that's this. 6 and 5 will make 11. So what we want to do is we want to make 1 6, 1 5. The signs will be the same, minus and minus. Okay, now check your work. The outer will be negative 5x. The inner will be negative 6x. This adds up to negative 11x. So we're sure we have factored it correctly. Now we can go ahead and solve. So x is equal to 6, or x is equal to 5. Over here, we're going to split up the x, and what makes 21 is 21 times 1, or 7 times 3. I know that one of them is going to be positive, one's going to be negative. I want it where the difference is going to be 4, and that's what I want to use here. So I'm going to have a 7 and a 3, and I want more negatives than positives. How do I know I'm right? I do inner I do outer, and I can see that adds up to negative 4x. So I can now set each factor equal to 0. So we get x is equal to 7 or x equal to negative 3. This is the end of part 1.